In this video, I am going to solve the second order non-homogeneous differential equation using the variation of parameters. And the variation of parameters method, it actually employs two different things. One is the homogeneous solutions, another is the Wronskian, and they use the Wronskian and homogeneous solutions along with coefficient of y double prime to find the particular solution. Once you find the particular solution, you have the homogeneous solution, and you can add these two to get the general solution. Let's go ahead and actually do it. So my homogeneous part is going to be y double prime minus 4y prime plus 3y is equal to 0. And our answer format is going to be e to the power RT, and the characteristic equation is going to be r squared minus 4r plus 3, right? You take the derivative, first and second derivative of e to the power RT, and plug it into this equation. You're going to get this times e to the power RT is equal to 0, but this cannot be equal to 0 because it's an exponential function. Therefore, the r squared minus 4r plus 3 is going to be 0. If you factor it, it's going to be r minus 1 times r minus 3. And I hope that you know how to do it. The factoring is going to be 4r is going to be broken into negative r and negative 3r. Then you can factor it out. So my r1 is going to be 1 and my r2 is going to be 3. So my homogeneous solutions are going to be e to the power t and e to the power 3t. Now we are going to go ahead and find the Wronskian. Wronskian is something very simple to find. You find the determinant of this, so it's very easy. So let's say e to the power t is 0, y1, e to the power 3t is 0, y2, so it's going to be y1 prime in the first column. And in the second column is going to be y2 and y2 prime. And you take the determinant of it. And that's going to give you, so determinant of e to the power t, derivative of e to the power t is e to the power t, then e to the power 3t, and derivative of e to the power 3t is going to be 3 e to the power 3t, and that's going to give you 3 e to the power 4t if you find the determinant, minus e to the power 4t. So your Wronskian is going to be equal to 2 e to the power 4t. Now we are going to go ahead and find the particular solution for this differential equation. So it's going to be y sub p is going to be equal to negative y1 times integral y2 times g of t, all of it divided by a of t times w integrated with respect to t plus y2 times integral y1 times e times g of t, all of it divided by a of t times the Wronskian integrated with respect to t. And let me go ahead and break this down for you. I wrote down a bunch of symbols here, and let me explain to you what they mean actually. You know, the general structure for second order non-homogeneous differential equation is this. A of t is y double prime plus b of t times y prime plus c of t times y is equal to g of t, where a, b, and c and d are functions, continuous functions on the interval under consideration. Okay, so that's where the a of t comes from, which is the coefficient of y double prime. And Wronskian is something you already know, and g of t is the right hand side. In our case, g of t is going to be e to the power 2t. And y1 and y2 are the solutions to the homogeneous equations. So this is my y1 and this is my y2. Now I can go ahead and find the particular solution. Y sub p is going to be equal to negative y1. So y1 is e to the power t, right? Negative e to the power t integral e to the power 3t y2, remember? And then g of t is e to the power 2t right here. That's the non-homogeneous part in the equation, the right-hand side, e to the power 2t, all of it divided by a of t. Remember, a of t is the coefficient of y double prime. In our case, coefficient of y double prime is nothing but 1. So it's going to be 1 times w. W is 2 e to the power 4t. 2 times e to the power 4t and dt. That's the first term. And the second term, y2, is going to be e to the power 3t. Integral y1 is e to the power t, and g of t is e to the power 2t. All of it divided by 1 times w, which is 2 times e to the power 4t, and integrated with respect to t. So now I'm just going to go ahead and find the particular solution. Negative e to the power t. I just need to find these integrals. I could bring the 2 outside, these 2. Then e to the power 3t times e to the power 2t. 2t is e to the power 5t divided by e to the power 4t is going to be just e to the power t dt plus e to the power 3t, then e to the power t times e to the power 2t is e to the power 3t, and of course I could bring these 2 right underneath, right? So e to the power 3t on the top, e to the power 4t at the bottom, so it's going to be 1 over e to the power t, or integral e to the power negative t dt. And that I could simplify a little further. Negative e to the power t over 2 times integral of e to the power t is e to the power t. All right. Then plus e to the power 3t over 2 times e to the power negative t. Integral of that is going to be negative e to the power negative t. Okay. Now let's go ahead and simplify it even further. Y sub p is going to be negative e to the power 2t over 2. That's just this term. And then minus e to the power 2t over 2. Okay. So let's see. Okay, so that gives me just negative e to the power 2t. All right, because 1/2 e to the power 2t negative, right? Negative 1/2 e to the power 2t. So that's going to be e to the power 2t, but negative. So your particular solution, y sub p, is going to be negative e to the power 2t. So that's the particular solution, right? Now your general solution is going to be y of t is equal to y sub h of t, right? Homogeneous part of the solution plus y sub p of t. Now, y sub h of t is just the linear combination of y and y1 and y2, right? So it's going to be c1 e to the power t plus c2 e to the power 3t, right? Then particular solution, we found it to be negative e to the power 2t. Negative e to the power 2t. So your general solution is going to be y of t is equal to c1 e to the power t plus c2 e to the power 3t minus 2 minus e to the power 2t, e to the power 2t. And this should be your general solution to this differential equation. I hope that this discussion was helpful. Thank you very much.